Magnetism and matter. In this chapter we study natural magnet, which is magnetite. Due to its attractive property it is called kissing stone. Due to black color it is called black stone, and due to directional property it is also known as leading stone. When ordinary piece of iron is rubbed with natural magnet, it also acquires magnetism, and these magnets are called man-made magnet. When electric current is passed through a coil, it behaves as an electromagnet. A rectangular shaped man-made magnet is called bar magnet or magnetic dipole. The product of either pole strength and the length of the magnet is called magnetic dipole moment. There are some properties of magnetic dipole. Magnetic monopole does not exist. The path along which an isolated north pole will tend to move if it is free to do so is known as magnetic lines of force. The properties are similar to electric lines of force. The only difference is that these are closed continuous curves starting from north to south pole outside the magnet and from south to north pole inside the magnet. Magnetic lines of force of bar magnet are similar to that of solenoids. Formulas of magnetic field due to magnetic dipole on its equatorial line, on its axial line, effect of external magnetic field on it, and energy stored in magnetic dipole. Difference between electric field and magnetic field, electric lines of force and magnetic lines of force, and effect when bar magnet is cut into two pieces. Total number of magnetic lines of force passing through a surface is known as magnetic flux. The number of magnetic lines of force passing per unit area is known as magnetic induction or magnetic flux density. Since any closed surface does not enclose any magnetic flux, so Gauss line magnetism, that is closed integral of B dot ds, is equal to 0. The magnetic field that exists in vacuum and induces magnetism is called magnetizing field. The extent to which a magnetizing field can magnetize a substance is known as magnetizing field intensity or magnetic intensity. It is denoted by H. The extent to which a substance is magnetized when placed in magnetizing field is known as intensity of magnetization, denoted by I. The ratio of intensity of magnetization to intensity of magnetizing field is known as magnetic susceptibility. The ratio of magnetic induction to magnetic intensity is known as magnetic permeability. The ratio of magnetic flux density inside the material to magnetic flux density in vacuum is known as relative permeability. Relative permeability is equal to 1 plus magnetic susceptibility. Magnetic materials can be classified into three categories: diamagnetic, paramagnetic, and ferromagnetic. Diamagnetic substances are feebly magnetized in the direction opposite to magnetizing field, for example, water, alcohol, silicon, marble, glass, etc. Electron theory states that in diamagnetic substances there are two unpaired electrons and the magnetic moment lies opposite to each other, so cancel each other. On placing inside magnetizing field, small magnetic moment develop but in opposite to magnetizing field. Paramagnetic substances are those substances which are feebly magnetized in the direction of magnetizing field, for example, aluminium, chromium, manganese, platinum, calcium, antimony, etc. Electron theory states that in paramagnetic substances there are single unpaired electrons which have magnetic dipole moment, but the total magnetic moments inside the substance are randomly oriented, so no net magnetic field. But when this substance is placed in external magnetizing field, then all the magnetic moments align themselves in the direction of magnetizing field, so substance has net magnetic dipole moment. Ferromagnetic substances are those substances which are strongly magnetized in the direction of magnetizing field, for example, iron, steel, nickel, cobalt, etc. Ferromagnetic substances also have unpaired electrons. Domain theory states that within a small volume called domain, all the magnetic moments have common direction, but the magnetic moments in different domains have different directions, so net magnetic moment of the substance is zero in absence of magnetizing field. On applying magnetizing field, all the magnetic moments of different domains quickly align themselves in the direction of magnetizing field, so substance get net magnetic moment. Then there are some properties of diamagnetic substances, paramagnetic substance, and ferromagnetic substance. For example, for diamagnetic substance, I is small negative, chi is small negative, mu r is less than 1. Whereas for paramagnetic substance, I is small positive, chi is small positive, mu r is slightly greater than 1. For ferromagnetic substance, I is large positive, mu r is large positive, and mu r is extremely larger than 1. Then there are numerical based on the formulas used in this chapter.